Hi there, this is Dirk, and I just wanted to share some observations with you guys about using the Apex Physics Lab, and I'm using PhysX 2.8. I'm going to be using it, first of all, to show the flexibility, but also to show that maybe sometimes models are not really suitable. So we've chosen the module within the Apex lab that creates destructible objects or prefractured models. I'm going to import my 3D mesh, and I've got an F-16 and a jet icon here that really stand for the same thing. They're the same model. And as I import it, first of all, it gives me a whole bunch of error messages because it doesn't like the way the texture image is applied. And secondly, if you look at this model carefully, you'll notice that it has a ground plane underneath it, so that, as I can show it to you, I don't even remember where I got this F-16 model, but the thing is, there's an obvious problem. If we wanted to use it in a game, we would have to open it up in a model editor, and we would have to remove the ground plane that's under it. Because otherwise, I mean, it was added presumably by earlier authors so that it could be used, so that the plane would cast a shadow, right? So let's see here. Let's just prefracture this object for the moment. We'll go into cutout mode, which means that I get to choose a fracture map, and I'm going to use a generic one like this, asphalt as it's called. And it's oriented the wrong way, which is a standard thing. The Apex Lab starts orienting everything according to X. In the view, we can actually enable more than one orientation for the fracture map, but I would rather just work in one direction. And is there anything else I need to do here? Not really. I don't think there's anything else here that I initially need to do. The random number generator has as purpose to add internal complexity to between the blocks. I don't need it, and therefore the amplitude of this backface noise is 0. And so I'll tell it to fracture. I'll show you what I mean. It's not done yet. So here's my fractured model. And one of the possible reasons why the entire rectangle seems to have fractures is what I was hinting at before. It's not really a 100% suitable model, and yet I can use it anyway. I mean, I've uploaded another video in which I use this very model. But if I now go into the playground, tools, and here it says playground mode, F12 will do the same thing. I'm given a hammer, and I hammer, and there's a huge amount of parts that go flying everywhere. Well, over 50% of that came from the ground plane. It did not all come from that little plane, because after all, the ground plane has as much surface area as anything else does. My damage is only 1.0. It doesn't seem to require a lot of damage, right? So the thing is, a lot of parts will go flying. People will ask, did that all come from that little plane? And the answer is no. And yet, back in the authoring mode, I can perfectly well go into my assets panel, and we must select which of these blocks we want to export as part of our asset. We're going to make it everything. So Control A selects everything. And then it tells us that our support depth, because one of the things that we sometimes want models to do is to have support even if pieces are logically missing. We don't necessarily want everything to fall over just because a part is missing. So we're going to put internal support, form extended structures, an extended structure. This means there will be one support graph common to anything that's selected. Well, the thing is, we've only selected one object, so it doesn't matter. Selected chunks, so everything will be supported, and what it says here, world overlap, Everything will be supported that overlaps with the world. Actually, I like that option. What overlaps with world static structures will be supported. World overlap. And of course, we apply it here. And I'm going to say the volume threshold is quite high. This has to do with reduced rigid bodies. Anything that's below this threshold in overall volume will be treated as a reduced rigid body, simplifying its physics later on. Just to conserve, I put 25 in there, just to conserve CPU usage. And then we go up here to File and to export the asset. And as was once said, the file formats that are available that are of interest are the Apex binary and the Apex XML, which is text. And I'm going to stick with binary here. You'll notice that I've already got a Destructible F16 selected. I'm going to select it again just to override what's already there under unrendered models. In fact, I'm actually going to go to a different folder. I'm going to leave the one that's there and I'm going to go to a separate folder. I've got it again. Here it is. And I hit save. We get this warning saying the prefractured data is not up to date. Do you want to proceed? This is routine. We say yes, and we overwrite the existing file, and we allow it to compute. And in fact, it may not have much to compute. It may be all done and finished here, as far as we know, so that we should be all finished, because it would be telling us if it hadn't finished. So we exit the PhysX lab. It will ask us, do we want to save the project that we have here, the scene that we have here? My answer is no. And I'm done with the PhysX lab. So now, as we go into our UDK editor, our Unreal Development Kit editor, we open it up. Let's see what it tells us. Sometimes it's well behaved. So the thing is, you get a little splash screen. The PhysX mode is going to stay in CPU mode up here, because the GPU mode for PhysX is really only applicable to particle fluids and to cloth within the PhysX 2.8 framework. So I'm going to select a package that I have called Apex. I click on Import, and again, I'm right where I'm supposed to be, so the Destructible F16 is right here, because this is CGI Local Apex. We open. With any luck, this will work. There is our Destructible F16. Especially when working with desktop capture software, it's important to click the object first, and then to drag, and we may still not be successful at dragging this. If I drag it out to here, it will be projected to an infinite distance, because all of these screen positions translate as rays into the scene. So I'm going to drag it to a screen position that lands at a known distance from the camera. There it is. I'm going to close this object browser for the moment, and I'm going to translate this a little bit higher, so that it's not on the ground anymore. And there's a little tiny dot right here. Okay, well, the thing is, I'm going to scale this now uniformly. Right, and so we see what I said before. This particular model has various aspects to it. It has that large ground plane to it. I want to rotate it so that it's facing correctly. So I begin by rotating it this way 90 degrees, and now I rotate it in the other direction 180 degrees, well, minus 180 it turns out, in the direction I'm using my pointing device. There we go. And now translate again. If I'm going to use this model, which amazingly enough works, then the only logical thing to do is to position it so that the ground plane disappears below the ground of my scene, right? So then the ground plane is at least not as conspicuous. And if this was some type of a military game where you're shooting at fighter jets, you would wonder whether this thing should have its landing gear extended, right? Now let's open up our object editor again. I want to create a little actor here because I want to have something to hit this thing with. Under vehicles, there's a factory for the Scorpion vehicle. We click it first, and then we try dragging it. Let's drag it to here. Let's put the Scorpion here. There's our Scorpion. We leave the content browser in its default state. There's our Scorpion. Now let's play this game. We go under the play menu. We have play in active viewport. I kind of like that setting. So there we go. Our player lands. There's no falling damage scripted, so none takes place. Now the way to quote-unquote enter this vehicle is to hit the E key with the Unreal Engine or the Unreal Development Kit. So E. So that was already part of the effects of the vehicle. So let's see what happens to our destructible object when we shoot at it. See, you wouldn't think that such a tiny little airplane would have chunks like the one over there coming off it, or bricks like the one over here, and yet that's what seemed to come off it. Now I can keep shooting at this, but it's only been fractured to a certain degree. I'm getting things falling on top of me. Anyway, fun little exercise. So we had an unsuitable model, and yet the software was flexible enough that it allowed me to do what I wanted to do. And oh, this is not worth saving. So, thank you very much.